Welcome to Narayana online classes. Let us discuss some problems in center of mass today. As first question says, find the acceleration of center of mass of blocks of masses m1 and m2 in Atwood's mission. So Atwood's mission he is telling you, as seen, Atwood's mission means like this it is, we are very much familiar that one. Here it is m1 and m2 he is telling you. This is m1 and this is m2. He is telling you that m1 is greater than m2 it is. So that means m1 will be going downward, m1g, and m2g acting downward. So here it is, this is moving downward with an acceleration a and it is moving upward with an acceleration a only. So now here, so what we can take, a1 is equal to a2 is equal to minus a, because directions we need to consider. Then modulus of a1 is equal to modulus of a2 is equal to, as m1g is dominating, m2g is lesser. So acceleration is equal to resultant force by total mass. So resultant force F resultant by total mass I can take. F resultant by total mass I can take. Then what is that F resultant? m1g minus m2g by m1 plus m2 it is. That is A value. And now he is asking what is the acceleration of center of mass of Atwood's mission. So ACM is equal to m1a1 plus m2a2 by m1 plus m2 it is. So now a1 is equal to a2 equal to minus a, and that a value I am substituting here. Thereby substitution you will be getting the required answer. That is acceleration of center of mass is equal to m1 a1 means a plus m2 a2 means minus a by m1 plus m2 it is. Then m1 minus m2 by m1 plus m2 into acceleration into a. So that is m1 minus m2 by m1 plus m2 into acceleration of center of mass. It is a value. How much we got that one? A is m1 minus m2 into g by m1 plus m2 it is. m1 minus m2 by m1 plus m2 into gravity. So the final answer is m1 minus m2 whole square by m1 plus m2 whole square into gravity. So this is the acceleration of center of mass of Atwood's mission it is. So that is first question. Next second question, let us go for now. Two bodies of masses 6 kg, 4 kg, velocity, first velocity is this one and second velocity is this one respectively. Then the velocity of center of mass is. So yes, velocity of center of mass VCM is equal to m1 v1 plus m2 v2 by m1 plus m2 it is. So by substituting velocity of center of mass, m1 means how much? 6. Velocity 5i to minus 2j plus 10k plus m2. m2 is 4 kg into 10i minus 2j plus 5k by 6 plus 4, 10 it is. So then velocity of center of mass is equal to 1 by 10 into 6 5 ja 30, 4 10 ja 40. 40 plus 30, 70i, 6 2 ja 12, 4 2 ja 8, 12 8, 20 minus 20j, 6 10 ja 60, 4 5 ja 20. 60 plus 20, 80, 80k. So then by cancelling the 10 value, then velocity of center of mass 7i minus 2j plus 8k. So this is the answer for that question. Next question. Next question. Yes. Two particles A and B initially at rest move towards each other under mutual force of attraction at an instant when the speed of A is v and speed of B is 2v, the speed of center of mass. So here, solution, you can see, here it is A and here it is B. It is coming like this due to gravitational attraction it is. That gravitational attraction is internal force. Gravitational attraction. Gravitational attraction is internal force. Is internal force for system. So, center of mass will not move. Center of mass will not move. So, velocity of center of mass is equal to 0 it is. That is that question to you. And next, another question we can see. Yes. Two balls thrown at the same time in air while they are in air, the acceleration of center of mass. They are in air, he is telling you. So, first body upward and second body like this. First body, second body. For both of them, gravity downwards only. For both of them, gravity downwards only. Then acceleration of center of mass is equal to, this is m1, this is m2. So, m1 g downward plus m2 g downward by m1 plus m2. So, gravity taking common, acceleration of center of mass is equal to gravity it is equal to acceleration due to gravity it is. So, like this we can solve this question. Next question. Two bodies, different masses 2 kg and 4 kg are moving with velocities 2 meters per second, 10 meters per second towards each other due to mutual gravitational attraction. So, here again the same model due to mutual gravitational attraction. So, now mutual attraction is internal force. Mutual attraction is internal force. So, center of mass will not move. Center of mass will not move. So, velocity of center of mass is equal to 0 it is. So, that is about that one. Next question we can see. If two particles of masses 3 kg and 6 kg which are at rest are separated by a distance 15 meters. Separated by a distance 15 meters he is telling you. 15 meters he is telling you. So, this is 3, this is 6, separated by a distance 15 meters. Two particles are moving towards each other under mutual gravitational attraction, nothing but this is center of mass. So, mutual gravitational attraction means center of mass won't get affected. So, obviously this is r1 distance, this will move, and this is r2, it will move. So, now with respect to center of mass, m1 r1 is equal to m2 r2 it is. m1 r1 is equal to m2 r2. So, then r1 by r2 is equal to m2 by m1. So, m2 6 by 3. So, r1 by r2 is equal to 2 by 1. That is the distances moved by 3 kg and 6 kg blocks when they are meeting. They will meet at center of mass position, that is. So, that is about it. Next question. 2:1. This is the thing. Next. Two bodies 6 kg and 4 kg of their velocities, then their velocity of center of mass is again same model we have seen. So, velocity of center of mass is equal to m1 v1 plus m2 v2 by m1 plus m2 it is. By solving velocity of center of mass, masses and velocity substitution, thereby we will be getting 7i minus 2j plus 8k just before solved. So, that is about that question. Next question. A thin uniform ring. Solution you can see. A thin uniform rod of length L is bent at its midpoint as shown in the figure. The distance of the center of mass from the point O is, from this point O. Now let me show you the diagram here. So like this. So when you are bending this, original center of mass is here. Now for this portion, this is L by 2. And for this, only this mass if I consider, now the center of mass of this one is here. This is L by 4. And similarly for this one, this is the center of mass. So this is the first position and this is the second position. Now the center of mass of these two masses will exactly here, as because both the masses are same. L by 2 no? So now this is the new center of mass it is. And now he is asking what is this distance. So this is O and this is O dash. And this is some A, let us take. This is A and this is B. It is. Now triangle A, O dash I am taking. So now let me take from triangle A, O dash. You can see that one. So this is O dash. Original center of mass, new center of mass it is. And this is L by 4. And this is theta by 2. Half of the angle raw. Total angle is theta, no? Now this will be theta by 2. So from the triangle cos theta by 2 if I write. Cos theta by 2. Cos theta by 2 is equal to, one step let me write. Cos theta by 2 is equal to O dash. O dash by AO. O dash by AO. O dash by AO. So then cos theta by 2 is equal to O dash by AO means L by 4. Then O dash is equal to L by 4 cos theta by 2 it is. So this is the O dash is the shift in center of mass, that is L by 4 cos theta by 2 it is. Like this we can get that one. Next question. Yes. Two particles of masses 2 kg and 3 kg are projected horizontally in opposite directions from the top of a tower of height 39.2 meters with velocities 5 meters per second and 10 meters per second respectively. The horizontal range of center of mass of two particles is. So now you can see here, for example, let us see here. So here it is, this is the body. What are the masses given? 2 kg and 3 kg. So this is 2 kg and this is 3 kg projected. 2 kg and 3 kg. 2 kg is with 5 and 3 kg with 10. Let me take this is M1, U1. This is M2, this is U2 it is. Now what is the velocity of center of mass initially? Initial velocity of center of mass. Initial velocity of center of mass. So UCM is equal to M1 U1 plus M2 U2 by M1 plus M2 it is. So that is equal to M1 3 into 10 minus, because opposite direction or 2 into 5 by 3 plus 2 5, 30 minus 10 20 by 5, 20 by 5. What is the speed it is? 4 meters per second it is. That is the velocity, initial velocity of center of mass. Then it is height h given to you. What is the height given to you? 39.2. Then what is the range? So now one more step let us write. So here it is. Now velocity of center of mass is moving this side with 4 meters per second, and here it is falling downward. Then what is the range? He is asking you. So range is equal to, as it is horizontal projectile it is u root of 2h by g it is. This is u. Then UCM is how much? 4. Root of 2. 39.2 by 9.8. This height is given 39.2 ra. 39.2 by 9.8. 9.8, 4 ja it is. So 4 coming out 2. 4 into 2 root 2. 4 into 2, 16 root 2 meters. This is the range of that projectile where center of mass can be. How much distance it is moved means this is the distance it can move. Yes. Next one. See here. An object comprises of a uniform ring of radius capital R and it's a uniform chord AB. Chord AB, yes. Made of same material as shown. Which of the following cannot be the center of mass of the object? Which of the following cannot be the center of mass of the object? So now you can see. An object comprises of a uniform ring of radius R and uniform chord AB, not necessarily. Made of same mass. Made of same mass material, same material as shown. Which of the following cannot be the center of mass of the object? See here. For example, solution you can see. This is the rod. This is total mass of ring. Mass of ring is here. And here it is mass of chord. Mass of chord. Then the center of mass of these two, somewhere here it will be. Total center of mass, here it is. Okay? Definitely this is 0, 0. And here it is x, y it is. So x, y is equal to, what is that? Here this is length L, let us consider this is length L, this is, and here this is radius R, no, this is R. You can see. Now I am taking this point especially. This point especially. And now this is x, y. So here it is. This is radius R, no? This is radius R. This is radius R. Now I want the positions of this one, it is. Position of this one. So how to find that position? This is the x coordinate and this is y coordinate it is. So now y coordinate, how can I get? For example, if I consider this is the theta. If I consider this is the theta, for our convenience I am taking this is the theta. That is the theta it is. Now what are these positions here? How can we get these positions? So now theta is equal to, this is R. So now something it is x, y now. So here it is x cos theta. This is R. And now I want this thing. This is x and this is y. So definitely, see here, this point is obviously R if I consider. Then that is R means R cos theta and R sin theta. Less than that it will be. So how much it is less than? An object comprises of a uniform ring of radius capital R and its uniform chord AB made of the same material as shown. Which of the following cannot be the center of mass? That means if this positioning, if the center of mass is beyond this, it cannot be. The center of mass of this one and this one must be in between these 2 points. Must be in between these 2 points. So now let me show you what is the length of this chord it is. What is the length of that chord? Let me show you that one. So let me erase this thing, just let me erase this thing and need this thing. X comma y. Before going to that x comma y, first let me find what is the length of the rod it is. Yes, length of the chord, length of chord AB. What is that you can see? It is a right angle triangle, you can see clearly. So this is R, this is R, this is root 2 R. Exactly half will be having the center of mass of that one. We'll be having the center of mass of that one. So then what is that center of mass position? So this is a right angled triangle, you can see. Obviously here it is 45 degree, it is 45 degree. So 45 degree means, then what is this value? Root 2r. So here you can see, let me take that triangle outside, this triangle outside. This is 45 degree. 45 degree. Now this is root 2r means half of that length means this is r by root 2 I can write. Then here it is r by root 2 sine 45. And here it is r by root 2 cos 45. Okay, then what are the values? So here it is r by 2, this is also r by 2. Yes, I am going to another step. Then see here. And now this position is this value r by 2 and this value r by 2. Then the ordinates of this one r by 2 comma r by 2. And here it is 0 comma 0. Then the center of mass of these 2 points, nothing but this is 0 comma 0, yes. And this is r by 2 comma r by 2. Now the center of mass definitely less than this r by 2 comma r by 2. So center of mass must be in between 0 comma 0 and r by 2 comma r by 2 it is. That means less than r by 2 comma r by 2. X coordinate less than r by 2, y coordinate also less than r by 2 it is. So then what is that? R by 2 it is. So which of the following is not possible? So r by 3 possible, r by 4 possible. So this is possible, this is possible, this is possible. But if you see here, both must be same coordinates it is. So now this will not be the correct answer. So now what is asking? Which of the following cannot be? Which of the following cannot be the center of mass? So this is cannot be. This is cannot be. Yes. Like this we can solve this question. Next question. Next question. Yes. N equal point masses each of mass m are placed at the vertices of regular n sides of polygon it is. For example, see here. See here I am taking the hexagon. And now here mass, here mass, here mass, here mass, here mass, and this mass is removed. This mass is removed, then what is the shift in the position of center of mass it is? So shift is equal to minus of mass removed into d by mass initial minus mass removed it is. Mass removed into d by mass initial minus mass removed, that is minus of mass removed is m. D is distance between the vacant vertex has a position vector A. A position vector A he is telling, that means this is A given to you. M into A by how many total? Nm. In that one is removed. Then final answer it is. So shift is equal to B is equal to minus of A by n minus 1 it is. So that is the answer for you. Next, as 4 identical planks each of length L are arranged one above the other over a table as shown. Each projects a distance A beyond edge, one that below it. The maximum possible value of A for the system to be in equilibrium without tipping over he is telling you. So then what he is telling you? Arranged one above the other over a table he is asking you. Arranged one above the other over a table. So now here it is. This is the table he is telling you. Then what is the position of center of mass possible he is asking you? Yes, the center of mass of this one is first one. This is x1. Here it is x2. Here it is x3. And here it is x4. So for that, here it is A, this is A, this is A. Now let me consider this is the reference point. Now the total center of mass must lie here. Total center of mass at this edge we should be. Total center of mass must lie at this edge. Then from here, what is the center of mass position? L. Then what we can write? Solution xcm is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4 it is. Then xcm is equal to m1 is each and every mass is same x1 L by 2. Each masses are same only m1, m2, m3, m4 masses are taking common. x1 is at L by 2. x2 is at L by 2 plus A. L by 2 plus A plus L by 2 plus 2A plus L by 2 plus 3A by 4m it is, as 4 masses it is. So m gone. Then xcm is equal to, you can see here L by 2, L by 2, L by 2, L by 2, 4L by 2, 2A plus A, 3A, 3A plus 3A, 6A, 4L by 2 plus 6A, 4L by 2 plus 6A by 4. By 4 it is. So 2 2 ja. xcm is equal to L. And now 4L is equal to 2L plus 6A it is. So then 6A is equal to 2L it is. Then A is equal to L by 3. That is the projection of each one for you. Yes. Next. One more question. Yes. Two masses m1 and m2 are connected to the ends of a light inextensible string which passes over, yes, it is Atwood's machine given to you. Then solution he is asking, release it from rest. Then what is the acceleration of center of mass? Yes, we just solved. One more time let us solve, no problem. This is m1 and this is m2 it is. This is A and this is A. m1g, m2g it is. Then A is equal to m1 minus m2 into g by m1 plus m2 it is. Then acceleration of center of mass is equal to m1 a1 plus m2 a2 by m1 plus m2 it is. Substitution. Acceleration of center of mass is equal to m1 minus m2 into a by m1 plus m2 it is. By substituting that acceleration of center of mass here, acceleration value here, that value is m1 minus m2 by m1 plus m2 into gravity it is. So then by substituting, by simplifying that one, we will be getting the answer as m1 minus m2 whole square by m1 plus m2 whole square into gravity. Like this. Just now we calculated. Yes, once again, no problem. Yes. Next. A shell in flight explodes into n equal fragments. K of the fragments reach the ground earlier than the other. Then the acceleration of center of mass subsequently will be. So see here, solution if you see, there are n number of particles. In that, k particles already reached the ground. So here it is k. Then what is n minus k are in flight? They are in the air. So here for this g, this is gravity, and here it is gravity, here it is gravity, freely falling down. And here they are at rest, they are not in motion. So then acceleration of center of mass is equal to m1 x1, m1 a1, m2 a2 plus on by m1 plus m2 plus m3 plus on, where these all are at rest, these all are having. So n minus k masses. Acceleration of center of mass is equal to n minus k into m into g by n masses. So then acceleration of center of mass is equal to n minus k into gravity by n it is. So like this we can get the required answer. So like this we can solve that question. Next, one more. Yes, thank you so much. That's all.